over that has an amplitude of 3, that has a period of 180 degrees. Now, writing down the equation, there's just two things you have to do, and you did one of them perfectly. Let's say you want to base this on y equals sine x. As you know, y equals sine x has an amplitude of 1 and a period of 360 degrees. So we have to make changes to that. To give it an amplitude of 3, we just simply multiply it by 3. To make the period 180 degrees, we have to take its default period of 360 and divide it by 2. So I'm just going to put a 2 in front of the x right here. This has an amplitude of 3, and to find the period of this, we take 360, divide it by 2, gives us a period of 180 degrees. And that's going to look like the curve that you sketched, where the period is 180 and the amplitude is 3. So we go up to 3 and down to minus 3. Okay, question 4. So what we're looking at here is y equals 2 sine x minus 45, and we're to write it out as a cosine function. Now just to remind you, sine looks like this, and cosine looks exactly the same as sine, except it's shifted over 90 degrees to the left. So as sine starts down here, cosine starts up here. If I was to look at 2 sine x minus 45, so that's sine x, that's cosine x. If I was to look at 2 sine x minus 45, that minus 45 means I have to shift it to the right by 45 degrees. So instead of starting here, I'm going to start over by 45. And because it's times 2, that goes up to 2, and that goes down to, and that'll be farther down here, to minus 2. Okay, we've shifted this over by 45. Sine is at its apex at 90, so this is going to be at its apex at 90 plus 45. The 45, we've shifted it over, 135 degrees. If I was to think of this as a cosine function, remember a cosine function starts at the top. This is a cosine function that has been shifted over to the right, starting there. It's been shifted over to here, because this is where cosine starts, 135 degrees. So I could write down the equation. This is y equals 2, because our amplitude is 2, times the cosine of x minus 135 degrees. That's going to be the same as y equals 2 times the sine of x minus 45 degrees. Okay, and now finally our last question. And our last question states that we have a crankshaft, and there's a picture of it here. So the crankshaft that's part of an engine. You've got a piston pushing down, causes the crankshaft to spin. And it has a radius of 10 centimeters. Starts at the bottom, and we're to plot its height as a function of angle. Now, if we're looking at part of a rotating body that starts at the bottom, it's going to look like this. It starts at the very bottom, it's going to make its way up, make its way back down, make its way up, make its way back down. It's a trig function. And all we have to do is we can sort of arbitrarily decide where our 0 point is. I'm going to put the 0 point at the bottom. I'm going to say that that starts at 0. And the maximum height it's going to reach is going to be double the radius. It rotates around the center. And the distance from the center to the edge is the radius, which is 10 centimeters. So that's going to make its way up to 20 centimeters. And the period of this, the angle that it's going to have to rotate through to get through a full cycle, is 360 degrees. Because upon one full rotation, the part that was at the bottom, it'll rotate around 360 degrees and end up at the bottom again. I hope that helps, and after going over this, you can give me a call, and when you're ready, you'll write the actual test on this.